And to start off, we'll just review the steps we've been using to graph rational functions. The first thing we looked for was our non-permissible values, and then we're trying to determine if those non-permissible values are holes or vertical asymptotes. If they're holes, that's when things simplify, and then you'll graph whatever new equation you get after simplifying. If nothing simplifies, then all your non-permissible values will be vertical asymptotes. The second thing we look for is horizontal asymptotes or oblique asymptotes. And you remember there was 3 situations, right? Situation number 1 was the degrees are the same, then you'll have a horizontal asymptote at the coefficients of the highest degree. Situation number 2 was when there is a larger degree on the bottom. This will also result in horizontal asymptote, but if the larger degree is on the bottom, the horizontal asymptote will always be at 0, at y equals 0. And then situation number 3 is when you have a higher degree in your numerator. And this is a situation that will give you an oblique asymptote if and only if there were no holes. If nothing canceled out to make a hole, then there will be an oblique asymptote. Okay? Which ones occur the most on the exam? Well, since the exam started putting these questions on there have been lots of horizontal asymptotes. There has yet to be an oblique asymptote on the exam. So it sort of appears that they're choosing not to put that one on the exam, but we'll look at that just in case. But for the most part, you get vertical asymptotes and holes and horizontal asymptotes. And they've been liking to combine those. So I've seen questions that have vertical asymptotes, holes, and horizontal asymptotes all combined into one. But as of yet, no oblique asymptotes. Step 3 is where we found our x-intercepts, y-intercepts, and any other points we needed. So we just plugged in values if we needed another point. And then once we had got all the points that we needed, the final step, once you have enough information, you just graphed it. So that's a recap of the steps that we've used so far. And so every time in 2.3, the questions have said, you know, determine non-permissible values, find equations, determine domain. And it says use graphing calculators to verify these characteristics. What we've been doing all along is we've been graphing them, because that's what this unit is about. And when we get to section 2.4, it's going to be a review. We're going to graph more. So 2.3 and 2.4 is all about graphing. So let's look at the examples that we have here. So to find out what our asymptotes are going to be for step 1, looking at our non-permissible values, x can't equal 2 and x can't equal -2. When we write non-permissible values, we can put a line through that equal sign to say it can't equal that value. When we determine, as in this case, that those are both vertical asymptotes, the equations of your asymptotes are equations, so they will have an equal sign. It'll be a notation error on an asymptote to put a line through your equal sign, because on an asymptote's equation, you are figuring out what that equation of that vertical line is. So if we start sketching things off to the side over here, this is the equation of this asymptote. This is the equation of that asymptote. Step 2, which situation? Since nothing's simplified, we still use the original equation. If something's simplified, we would continue graphing with the simplified version. In this case, we have the higher degree on the bottom. That tells us we have a horizontal asymptote at y equals 0. Step 3, find all your intercepts. So the y-intercept is always the easiest because you can just plug in 0 for x. Plugging in 0 for x in this case gives you a positive 1. Then we find all of our x-intercepts. Our x-intercepts is when you plug in 0 for y. When you plug in 0 for y, you get 0 equals this fraction. And I've said this before, the only time a fraction is equal to 0 is if the numerator is equal to 0. So you just need to check the top, x minus 4. What would make that equal to 0? It would happen at 4. Now the interesting thing is this point is on our horizontal asymptote. But maybe by now you've started to get used to seeing that horizontal asymptotes aren't non-permissible values. They're there just to tell us what's happening to the graph when the graph gets to very large x values or very large negative x values. In step 3, after we found our intercepts and we found all of our x-intercepts and all of the only y-intercept, there's always only one y-intercept. Once we found that, we may need more points. Okay? Our vertical asymptotes separate our graph into sections. This graph has 3 sections. Given what we have, the only section that you could sketch right now is the middle section. Okay? And the reason I can sketch the middle section is because I need my graph to go towards those vertical asymptotes. How do I know it has to go up in both of these situations? Well, if one of them went down, can you see that I would get another x-intercept? And I've already found the only x-intercept that there is. So that's why x-intercepts are really important to find, because once you find them, you know that your graph will not cross that x-axis again. So we're able to graph the middle section, but we don't have any information to graph in this section, and we're going to need more information to graph in the last section because that graph could go up or down. I'm not sure which way it goes. So first of all, let's figure out this section. And we can just pick a random value in that section. I'll choose x equals -3. If I plug in x equals -3 into my equation, and I'll use the factored one, -3 minus 4 will give me -7 on the top. -3 minus 2 will give me -5, and -3 plus 2 will give me -1. This will simplify to -7/5. So I can plot that point. Oh, it'll be a little bit lower. -3, -7/5. And now that I have that point in that section, I know there's no more x values, and I know that as my graph continues, it will go towards my asymptotes, so that will look like that in that section. In the right-hand section, I'm going to plug in 3. I'm also going to plug in 5. The reason that I'm going to plug in 3 is to find out if my graph is going to go towards that x equals 2 asymptote. Is it going to go down towards that asymptote, or is it going to go up? And if I plug in 3, okay, so I'll get -1 on the top, +1 there, +5 there. That'll give me -1/5. That's telling me it has to go down towards that asymptote, because otherwise it would cross your x-axis again. And I'm going to plug in 5 to find out sometimes at that point 4, 0, it could have bounced off the x-intercept, or it could go above the x-intercept. So if I plug in 5, 5 minus 4 is 1, 5 minus 2 is 3, 5 plus 2 is 7. I do get a positive number. That means this graph is going up, and it might go up a little bit further, but then it's going to come back and head towards our asymptote. Again, our asymptote is there to tell us what happens when x gets very, very big. And you can see it in the equation. If you put a very large number in for x, like if I put in 1,000,000, I will get 1,000,000 minus 4 divided by 1,000,000 squared minus 4, which will create a much larger number in our denominator. And when you divide by a large number, you get closer and closer to 0. Okay, graph number 2. Factor completely to start. Difference of squares on the top, difference of squares on the bottom. X plus 2, x minus 2, x plus 3, x minus 3. X can't equal -3 and x can't equal 3. None of those non-permissible values cancel out, so these will both be vertical asymptotes, one at -3 and one at +3. Step 2, determine whether or not you're going to have a horizontal asymptote or a vertical asymptote. The highest degree in this is an x squared. There's an x squared on the top and an x squared on the bottom. That means the degrees are the same. And we'll have a horizontal asymptote at y equals 1. Again, start with your y-intercept. It's the easiest. Plug in 0 for x. And you'll get +4/9. Again, to find your x-intercepts, plug in 0 for y, and the only time a fraction is equal to 0 is if your numerator is equal to 0. In this case, we're going to get 2 x-intercepts. We're going to get one at -2, 0, and the other one at +2, 0. So based on our x-intercepts, we've got a lot labeled in our section in the middle. We don't quite have enough to graph our middle section. I do know that it's going to look like this, okay? But the question that I have is, which way does it go? It could bounce off those x-intercepts and go up, or it could go down towards the asymptotes. How would I find out? I would have to plot another point. Maybe I'll use 2.5. Okay? And I'm going to show you what I'm really concerned about is when I plug in 2.5, I'm concerned, is that number going to be positive? Because if it's positive, it bounces and goes up. If it's negative, it goes down. And so what I'm going to do when I check 2.5 is I'm not going to worry about the mental math of having to multiply a whole bunch of decimal numbers. I'm just going to worry about when all of these things go in, what's positive and what's negative. So if I plug in 2.5, would you agree that 2.5 plus 2 will give me a positive number? 2.5 minus 2 will give me a positive number. 2.5 plus 3 will give me a positive number, and 2.5 minus 3 will give me a negative number. If you multiplied two positive numbers on the top and multiplied a positive and negative number on the bottom and then divided, will that answer be positive or negative? Well, what's that one negative going to do? It's going to keep everything negative, so I know that in this section, it goes down. Similarly, I could test negative 2.5. Negative 2.5, this will be negative. This will be negative. This one will be positive, and this one will be negative. 3 negatives multiplying and dividing. Will that be positive or will that be negative? It'll be negative as well. So the middle section took a little bit more work. Even though we had 3 points in that middle section already, we had to do a couple more points just to make sure we knew which way it was going towards the asymptote. We still have 2 sections that we don't know what's happening in those sections, so we will plug in negative 4 and we'll plug in positive 4 to find some values. If I plug in negative 4, I'm going to get negative 2, negative 6, negative 1, and negative 7. Multiply that out, I'll get 12 over 7, which is slightly bigger than 1. So that tells me my graph in this section looks like that. If I plugged in positive 4, positive 4 would give me 6, 2, 7, and 1. It also gives me 12 over 7. And if you looked at the original equation, it might make sense that plugging in negative 4 and positive 4, because they're squared, isn't going to make a difference. That you're going to get the same number when you do that. So that's why we got 12 over 7 in both ways. Okay, so we didn't get much time to practice last class on these. Again, from example 1 and 2, I had given you 5, 6, and 7 to do, and from example 3 today, 9 and 10. And even though those questions say, some of them might just say, just find horizontal asymptotes, or just find your vertical asymptotes or holes, I want you to graph every single one of them to get practice, okay? After you've graphed one, if you want to check if your graph is correct, you can type it into your graphing calculator and see if you've got the same graph that your graphing calculator produces.